and then actually what goes on. So these will be available to you from now on. And we have hard copies that I'll do as we go along. And we're looking at module 7, right? And we're looking for the step chart. So this is their step chart. So they went up this way. They pick up cylinder 1A1 and 1A2. So let's turn ours around. We can see what we need. And then the gripper will be over above the gripper. And then the brake for the traverse brake, and then the traverse cylinder. Okay, so what do they say? We need to start this. First, they didn't put this. We got to have the start, right? 1B1 has to be, so 1B1 is retracted, so it's got to be retracted. 2B2's got to say it's what? We're not using that. And then 4B1 has to be 0. Y'all understand why? Because it's a through the beam. Y'all understand? Through the beam. Well, yeah, because it's an optical interrupter, and what happens is I needed to bring up PowerPoint before I did this. Okay. So what I've got is it's what we call a through the beam sensor, but it's also called an optical interrupter. So what it's doing is shooting a light beam, a beam of light from a transmitter to a receiver. So right now, when nothing's in the blade, then this thing is going to give me a 1. If something's blocking the blade, it's going to give me a 0. So 4B1 is up inside. It's got that flap right there, and it's inside that. That's why we know that it's at the home position or the left retract, what they call the electric retract. So we want 4B1. We want it to equal a 0. I know it seems kind of strange, but that's when it detects something, it gives us back a what we call a logic 0. And when it don't detect something, it gives us back a logic 1, right? You understand that? Yeah, well, it's very easy to do because normally you say when something's there, it's going to say it's there with a 1, but not this guy. So this guy gives us back, if it sees a light, it gives us back 24 volts DC. If it breaks, it gives us back 0 volts DC. So digitally, we would call this a logic 1, and we would call this a logic 0 in digital. Because 0 in binary, we've only got 2 states. It's either, but what is true and what is false depends on what you say, right? You understand? So which one's true and which one's false? 0 or 1?
The 1's supposed to be true.
Well, no, it's up to you to determine. See, but when you program a PLC, you determine which is true. And if you had PLCs yet, Eric? So we have something we call examine close, and we have one we have examine if open. Right? You understand? This right here, a 1 is true. This right here, a 0 is true. And that's the difference. So when you use an examine close, you're saying a 0 is true. I'm sorry, I got that backwards. This is a 1 and this is a 0. So this is true if the switch is open. The other one is true if the switch is closed. Right? You understand? But when that sensor gives me back a 0 or a 1, when that push button gives me back, it gives me a 1 if it's closed, it gives me a 0 if it's open, and you decide if a 1 is true or a 0 is true. So if you use examine in true, so if I was to look inside the memory that picks up this, if the switch is if the push button is closed, then I'll get back a 1. If the switch button is open, it gives me back a 0. But in my program, if I use an examine if closed, then a 1 is true. If I put an examine if open, then a 0 is true. So what's true, a 1 or a 0? Well, it all depends on what you define as what is 1 and what is 0. It's just like I could have a glass of water up here, and I could say, well, it's true if it's empty, and it's false if it's full. It's up to you to decide what's a true and what's a false. So we got this guy right here. This is called an AND gate. This says a voltage is true. If I come over here and put those circles right there, that says a low is true or 0 is true. So we identify what's true and what's false. So what this guy's looking for something to be in that blade. In that interrupter. So it's saying that 4B1 has to be what? It's got to be false. It's got to be a 0. In this situation, it would be true. Okay. But when I wrote my PLC program, which contact am I going to use to represent that input? So if that's all true, then what can we do? We can extend the pickup cylinder. This is going to trigger 2B1, right? And this guy right here is still, now, this guy right here should go to a 1, but it's not looking for that to be a 1 anymore. It just looks, it's not looking for it to be a 0 anymore. It just required it to be a 0 to start the motion. Okay, you understand that? And then up here, so the pickup center extends the brake. According to this, the brake doesn't come on. The brake doesn't come on to this guy over here. I'm almost sure right this right. Huh? Yeah, but I thought it came on anytime. We would have to go look at that. I thought it came on anytime it extended or retracted. So according to my rationale, it should follow this guy up here. You understand? So, but we'd have to go check that out, because according to this, it don't. According to this, the brake doesn't get energized until the 4th step, which is it looks like they're energizing the brake. I don't know. Let me look at that. So what we'd have to do is figure out exactly what's going on with the brake. This guy right here, but the traverse 4B2 indicates it's on top of a blade, right? You understand? And this is going to be different too. So, so this says the traverse is not at its home position, and that's not exactly true. You understand what I'm saying? So this step chart is not right. Yeah, because now it's blocking a blade, which is fine. Okay, so this is blocking a blade. But what is it? So this is not the step chart for this thing. So let me pause this and let me show you what I'm talking about. So let's look and see what the function chart says. If the function chart is right, then we can use that to develop a step chart, right? So this will be in course content. manufacturing lines. And then Armatrol. In Module 7, which is the part storage section. And then we're looking for the function chart. So what it's got to do is it's got to, so notice here, so extend the pickup cylinder, that's true. It's going to trigger, so to start it, start, right, it's going to trigger 1B1, 1B2. If 1B2 is true, then it's going to do what? Well, close the what? Gripper. Then what's it going to do? Retract the cylinder, and then what's it going to do? Traverse. What does it also do? Yeah, which releases the brake. Yeah, that's what it's doing. It's putting pressure, so pressure releases the brake, which is normal. So if we lose pressure, the brake comes on. This is one thing we had to do on our robots over there. So normally what we want to do on our robots, if you lose pressure, if you lose electrical power, you want the gripper to open or close. You want it to close. Amerex, when they sent their robots, you turned it off to open it. So all we did was swap the pipes around. There's another thing though that's missing out of their function chart. Retract the cylinder, open the cylinder, retract pickup, release the brake, retract the traverse, retract the brake cylinder, engage the brake. So what else, even in their function chart, what they gonna put in here? Of course, it's going to be a little more complicated. But when Siemens, these are Siemens function charts. So why did they totally ignore? They ignored the count, right? You understand? So this, what they've got to be using. Y'all have had PLCs and y'all got through counters, right? So it'd be real easy for me to count when those pulses come across. So every time a blade covers up, we would count, right? In the first count, we would look for a count of 4. And when it hit 4, we would stop it and we'd drop it. The next time we'd look for a what? Then we'd decrement the count, which means now we're looking for a count of 1, 3. And then the next time we'd decrement the count, and then we'd look for a count of 2. Then we'd decrement it, we'd look for a count of 1. And then what would we do? We had reset the down counter. It's going to be a down counter, right? You understand? And what you would do is every time the counter counted down, then you would stop. So when Siemens did this, they totally ignored that. Now here they did use the brake. So it looks like the step chart was okay, except they got the brake completely backwards. Well, maybe not. Maybe we're looking at it wrong. Okay, so they're right. So they say retract. So when they retract it, they're turning the brake. So it's kind of hard. So when they retract it, they're doing what? So this would be better to say brake on and brake off. When they say retract it, then the brake is on. When they say extend it, the brake is on. Or the brake is off. So this is right. This step chart does go according to their function chart, but they're completely ignoring where to drop it at. Right here, 4B2, and 4B2 is true. 4B2 detects that blade, and what does it do? It extends the cylinder. All right, you understand? But 4B, this is true. They don't tell us which chute it's dropping in. So we're okay. Y'all don't have to do that. So I just read it wrong. So what we need to do, guys, we need to put the line back together, and we need to make sure it runs, because we're going to. By the way, Sarah Versa is supposed to be here tomorrow at 10 o'clock. I don't know what y'all are going to be doing. You're more than welcome to come over if y'all want to. Who knows, you might get on the news. Yeah, tomorrow. You'll be with Brittany? Yeah, well, we're going to double up on that class. Business casual, right? So.
She coming to the robotics class?
Who's that? No, she's coming over here, so she's going to be at both of them. Are you in?
I'm in robotics.
Yeah. So our robotics class will come over here, and then Brittany's, whatever class Brittany's in, which is Alfred's in that one, is so we'll be over here. We'll have a group over here for us. But it's going to be, so you'll be here. Randy, you're tomorrow night. You're probably working. You probably. So yeah, you know, she was going to come during our class, but that's when Harvey came through, so they did reassign her. So y'all two will be here. So.